Think about artificial feeds. Sometimes uneaten feeder waste contributes to nutrient loading, maybe eutrophication.
Right, water quality issues.
Exactly. Live feeds, on the other hand, can actually help water quality. They graze on algae, acting like tiny natural filters in the system. Plus, they tend to stay suspended nicely in the water column. That means larvae can find them easily, everywhere. Better feed conversion, less wasted energy hunting for food.
Less waste overall.
Precisely.
A whole new era of communication in the global aquaculture industry is coming. Now you have the brightest minds in aquaculture right in your pocket. And what's best? You can listen to all of them while driving to a farm, traveling, or running errands. It's never been this good, and it's never been this simple. Welcome to the Aquaculture Podcast Show, the first AI-based podcast in aquaculture, where you'll find cutting-edge insights in everything that's working in aquaculture, nutrition, health, and production.
Welcome back to the deep dive. You know, if you're involved in aquaculture, scaling up sustainably is, well, it's the name of the game. But maybe the key isn't some far-off tech. Maybe it's mastering something tiny. Today, we're diving into zooplankton. They seem small, but their role is surprisingly massive for the health and, frankly, the economics of aquaculture. So our mission today is to unpack exactly why these microscopic organisms are so fundamental. We're talking healthy development, economic viability, the whole picture. We're digging into the latest thinking on their nutritional value, their cost effectiveness. Okay, let's get into it. Let's start at the beginning. Those very early stages for fish and crustaceans, they're notoriously tricky, right? Why so vulnerable? What's the main challenge with feeding them?
Yeah, it really boils down to their biology. It's quite fascinating, actually. These larvae, these tiny juveniles, their digestive systems are just, well, they're incredibly immature. Often they don't even have a proper stomach yet.
Yeah.
And they lack a lot of the essential digestive enzymes that older animals have. So that physiological immaturity means they absolutely depend on very specific types of food that's easy to break down, easy to absorb.
Makes sense.
And that's exactly where live feeds, particularly zooplankton, come in. They're uniquely suited. It's not just the nutrition profile, which is usually excellent, but also the digestibility. Their soft bodies are just perfect for immature systems. And there's more. Their movement in the water. That's a crucial feeding cue. It triggers that instinct to hunt and eat.
Right, something a dry pellet just can't do.
Exactly. It's dynamic.
Okay, so if live feeds are so biologically perfect, why do we still see so many artificial feeds dominating? What's the disconnect there? Seems a bit strange.
That's a really good question. It hits on the practical side of large-scale aquaculture. Artificial feeds, yeah, they're everywhere. They're easier to handle, easier to ship, and the upfront cost looks lower sometimes.
Right, the perceived cost.
Exactly. But they often struggle to match the bioavailability, how easily the nutrients actually get used by the animal. And the palatability, that natural appeal, it's just not the same. Trying to perfectly mimic nature in a pellet is, well, it's incredibly difficult. So the hurdle isn't really not knowing zooplankton are good. It's more the logistics, mass production, consistent supply. That's tough compared to just ordering bags of dry feed.
So going back to these larvae, these babies with incomplete digestive systems, what makes zooplankton the ideal first food? What's the secret sauce compared to artificial feeds?
What's really fascinating here is just how nutrient-packed they are and the variety. Different zooplankton species bring different strengths, but generally they're loaded with essential fatty acids critical for brain tissue development, plus high-quality protein, vitamins, minerals.
The whole package.
Pretty much. It's a complete meal, perfectly digestible.
Yeah.
Now, if we look at the types commonly used, rotifers are very popular. They're relatively easy to culture, quite tolerant of different conditions, so very practical. But it's fair to say their nutritional density isn't always the highest. It's a trade-off.
Okay.
Then you've got copepods. These are often seen as the gold standard nutritionally.
Yeah.
Fantastic fatty acid profiles, lots of antioxidants, really top-tier stuff.
Right.
But yeah, they're much harder to mass produce reliably. That's the big challenge with copepods.
Got it.
And then cladocerans, things like Daphnia and Moina, they kind of offer a middle ground, a good balance. Moina especially is interesting. It's quite tough, handles harsh conditions well, and shows real promise as an alternative to other live feeds, even when things aren't perfect.
That's a great overview. So nutritionally, they're powerhouses for the larvae. Let's zoom out, though. What about the broader impact? Economics, environment. How do they fit into the sustainability puzzle for the industry?
That's a key part of the story. Environmentally, zooplankton have significant advantages. Think about artificial feeds. Sometimes uneaten feeder waste contributes to nutrient loading, maybe eutrophication.
Right, water quality issues.
Exactly. Live feeds, on the other hand, can actually help water quality. They graze on algae, acting like tiny natural filters in the system. Plus, they tend to stay suspended nicely in the water column. That means larvae can find them easily, everywhere. Better feed conversion, less wasted energy hunting for food.
Less waste overall.
Precisely. And that ties into the economics. Look, setting up zooplankton culture takes effort, maybe more initial investment in labor, tanks, that sort of thing.
Sure.
But you avoid the storage headaches of dry feed. No spoilage, less waste that way too. And over the long term, when you see the boosts in survival rates, the faster growth, animals reaching market size quicker, healthier, it really starts to pay off.
So the return on investment is there.
Absolutely. There's solid data showing diets incorporating zooplankton lead to better growth, healthier animals, and actually lower overall feed costs compared to just relying on traditional protein sources. The profit index in many trials points clearly towards zooplankton being very cost-effective.
Okay, so the benefits are clear, but nothing's perfect. Are there ways to boost their nutritional value even further? And what about potential downsides or risks we need to manage?
Yeah, that's a really important question, optimization and risk. We can definitely enhance their nutritional profile. We use specific techniques, sometimes called bioenrichment or encapsulation. Essentially, you feed the zooplankton themselves nutrient-dense stuff just before you feed them to the larvae. Think specific microalgae, yeast, special oils.
Gut loading them.
Exactly. You boost their levels of key fatty acids, vitamins, minerals, tailoring the final product, basically. Different zooplankton respond best to different methods. Some do well with certain algae. Others really benefit from mixed fortified diets, maybe with specific trace elements added. It's about fine-tuning.
Okay, makes sense. And the risks?
Well, any live system carries some risk. Zooplankton can potentially carry bacteria if things aren't managed properly, especially in high-density cultures.
Like Vibrio, perhaps.
That's one possibility, yes. Especially noted sometimes with Artemia, for instance. And if you were sourcing from the wild, which isn't common for controlled aquaculture feed, you'd worry about contaminants, metals, pesticides, microplastics maybe.
So controlled culture is key.
Absolutely essential. You need clean starter cultures, rigorous protocols, good water quality management, basically biosecurity for your feed. Some types, like rotifers, might naturally carry a bit more bacteria than, say, copepods, which generally seem lower risk pathogen-wise. It's just something to be aware of and manage.
It sounds like there's constant work to improve things. What's next? What's on the cutting edge for using zooplankton even better in aquaculture?
Oh, the field's moving fast. There's a lot of work on the genetic side. People are characterizing different strains, looking at selective breeding, aiming for zooplankton that are easier to culture reliably, grow faster, and pack even more nutritional punch.
Breeding better feed.
Essentially, yes. And then there are logistics, things like improving cold storage or even cryopreservation of dormant eggs. That could be huge for supply stability. Imagine having seed stock ready to go whenever you need it, without maintaining constant live cultures.
That would be a game changer.
It really would. Plus, there's research using genetic tools to maybe enhance their resilience, make them tougher against environmental stress, or even naturally occurring toxins. Lots of potential there.
So pulling this all together, it really seems zooplankton aren't just nice to have. They're pretty much indispensable, especially in those critical early stages. Their digestibility, nutrition, the environmental angle, it's a combination that artificial feeds just struggle to replicate fully.
That's right.
So the evidence really stacks up. Despite the challenges, the culture techniques, the logistics, the long-term payoffs in performance and economics seem significant.
Definitely. And the future looks like integrating these live feeds smartly, using those enrichment techniques, maybe co-feeding strategies alongside specialized artificial diets, optimizing the whole system. That's how we push towards more efficient, more sustainable aquaculture globally. Zooplankton are absolutely central to that vision.
So what does this all mean for the bigger picture?
Well, think about it. Given how foundational they are and all the innovation happening, could mastering this micro world of zooplankton actually be the macro solution we need to really scale up sustainable aquaculture for the future?
If you enjoyed this episode, make sure to follow the Aquaculture Podcast Show on your favorite platform. And don't forget to follow us on LinkedIn, Instagram, and Facebook to stay updated on the latest episodes and industry insights. Thanks for tuning in, and we'll catch you next time.